This video is presented to you by www.testprepadda.com. Dear students, in the previous sessions of trigonometry, we have learnt about trigonometric ratios, basic identities, angles, trigonometric ratios for different angles, then domain, range, graphs for different trigonometric functions. In this session, we will talk about compound angles, and we will also find the identities related with compound angles. First of all, what are compound angles? What are compound angles? I'll give you the definition first of all. An angle made up of the algebraic sum of the two or more angles is called a compound angle. I will write this definition for you. An angle made up of the algebraic sum of the two or more angles is called a compound angle. Algebraic sum. I'll give you example here. For example, if I take if A and B, if A and B are two angles, then algebraic sum means A plus B, A minus B, B plus A, B minus A. These will be called what? Compound angles. Compound angles. You can see algebraic sum. Okay. Now, if there are three angles, if I give you A, B and C, if these are three angles, then different algebraic summations will be like A plus B plus C, A plus B minus C, A minus B minus C, A minus B plus C, etc. Many combinations are possible, are called what? Compound angles. Got the idea? Now we are aware of trigonometric ratios for one angle. Like we are aware of sine A, we are aware of cos A, we are aware of sec A, we are aware of tan A, we are aware of cot A, we are aware of cosec A. We are not aware of sin A plus B, sin A plus B plus C. Okay, in this session we will learn how to find trigonometric ratios for compound angles. Okay, I will start with sine A plus B. Sine A plus B. Let me write here. Sine A plus B. Okay, I'll start with sine A plus B. First of all, I'll take a circle. This is the circle. Let this as the center and a point P on the circle, another point Q on the circle. I will join O with Q. I'll take one more point on this circle. Let this as R. Okay. Now this angle is A. That means angle POQ, and let this angle as B. This is A, angle QOR as B. So what will be angle POR? It will be our compound angle A plus B. Got it? Now to find sine A plus B, what I do here, I will drop a perpendicular from this R on two lines OP and OQ. Let me select another pen to understand this in a better manner. I am going to drop a perpendicular from O. This is, let this point as S, and another perpendicular on this OQ line, let this as T. Okay, this is the 90-degree angle. Now I'll take a parallel line parallel to this OP line from this T, and let this cuts this RS line at point U. This is U. Okay, so this will also be 90-degree. Okay, now I'll drop perpendicular from this T point on this OP line. Let this as V. Now I will talk about the angles. Please look at this and listen carefully. POQ is A. And since UT or TU is parallel to this OP or OV, if this angle is A, this angle will also be A. You must be aware of this theorem. If this angle is theta, this angle will also be theta, because two lines are parallel to each other. And this angle, if A, this angle will become 90 minus A. And since this angle is 90, this is 90 minus A, this will become A. Means angle URT as A. Okay? Now, if I ask you with the help of triangle OT and V, tell me sine and cos of this A angle. So sine A will be what? Perpendicular, that is VT, upon hypotenuse, that is OT. Okay, what will be cos A? Cos A will be OV upon OT. Okay, now there is one more triangle where one angle is A, and that is RBT. If I draw here, I will copy as such. Here it is R, here it is U, here it is T. So, and this angle is A. So if I ask you what is sine A, this UT is perpendicular here. If UT is perpendicular, then sine A will be UT upon RT, and cos A will be what? Cos A will be base, that is RU or UR upon RT. Okay, now for sine B and cos B, I will take triangle. This is R, this is T, this is O. This angle is P. So if I ask you what is cos B, base, that is OT upon hypotenuse OR. And if I ask you what is sine B here, it will be perpendicular, that is RT upon OR, that is hypotenuse. So now question, you may ask, why have we found these sines and cosines? So I have found these trigonometric ratios, and this will help us in getting sine A plus B. Now how? First of all, sine A plus B. A plus B is there in the triangle. If I take this triangle, this as R, this as S, this as O. You just check this angle is A plus B. So if I ask you what is sine A plus B here, you will write as perpendicular upon hypotenuse. Perpendicular is RS, hypotenuse is what? OR. Okay, now RS, if you check this, RS is actually divided into RU and US. So I can write in place of RS, RU plus US upon OR. Now if I separate it, it will become RU upon OR plus US upon OR. Okay. Now if I multiply and divide, RT with this and OT with this, then what happens? I will write RU upon OR, and here I will multiply and divide with RT plus US upon OR. Here I will multiply with OT. Okay, now what happens? You just check RU upon RT. RU upon RT. Where is that? RU or UR both are same. UR upon RT is cos A. So in place of RU upon RT, I can write cos A. And what is left here? RT upon OR. What is RT upon OR? RT upon OR, sine B. Okay, sine B plus. Now look here. OT upon OR. What is OT upon OR? Where is OT? Here. OR. What is this? Cos B. Cos B. Okay, into what is US upon OT? US upon OT. US is actually VT. If you check, the two are parallel and same length. So, in place of US, if I write VT, and so US upon OT means VT upon OT. Where is VT upon OT? Here it is, sine A. So I will write it as sine A. Got it? So the final result comes. What is that? We have derived sine A plus B as sine A cos B plus cos A sin B. Very, very special result. So we have got sine of this compound angle. Got it? Now, if I replace B with minus B, replace B with minus B, then it becomes sine A minus B. Sine A minus B. And here what will you say? Sine A will remain sine A, but cos B you have to write as cos minus B, plus cos A will remain cos A, but sine B you have to write as sine minus B. Now, recall previous sessions of trigonometry. There we said cos minus theta as cos theta and sine minus theta as minus sine theta. Now substitute here. So it becomes sine A cos B, and sine minus B is minus sine B, so it becomes minus cos A sin B. So this way we get result sin A minus B, another special trigonometric identity. Okay, this was sine A plus B and sine A minus B. Now again, with the help of that circle, we will try to find cos A plus B. Okay. Now let me select another pen here. Cos A plus B. Just go and check there. If I take this triangle, cos A plus B will be what? OS upon OR. OS upon OR. So this will be equal to OS upon OR. Now, OS, can we break OS into OS? OS is what? OV minus SV. Okay, so I will write this as OV minus SV upon OR. I'll divide this OR. It will become OV upon OR minus SV upon OR. Okay, now again with this first term, I will multiply and divide OT. If I multiply and divide OT here, and if I multiply and divide RT here. Just check what is OV upon OT. OV upon OT. OV upon OT is what? Cos A. So there I will write cos A. And now OT upon OR. OT upon OR. You can check cos B. So I got this way cos B. Now minus check SV upon RT. SV upon RT. SV is actually UT. SV is actually UT. So SV upon RT means UT upon RT. And where is UT upon RT? UT upon RT is sin A. Sin A I will substitute there. Sin A. Now check RT upon OR. Where is RT upon OR? RT upon OR. RT upon OR is sin B. You can see here. Okay. So substitute there. Now sin B. Okay. So cos A plus B. Cos A plus B comes as cos A into cos B minus sin A into sin B. A very interesting identity. Okay. Now as we did in case of sine, here also if I replace B with minus B. Replace B with minus B. So cos A minus B minus becomes what? Cos A will remain cos A. In place of cos B, I will write cos minus B minus sin A. And in place of sin B, what will you write? Sin minus B. And as I told you, cos minus theta is cos theta, while sin minus theta is minus sin theta. So at the end it becomes cos A cos B plus sin A sin B, and this is what? Cos A minus B. Another very interesting identity. Please note that these identities are valid for all A and B angles. All A and B angles. Okay, so valid for all A and B angles. Now we have got sin A plus B, we have got cos A plus B, we have got sin A minus B, we have got cos A minus B. Now we will try to find tan A plus B. Okay? Tan A plus B. Tan A plus B is what? Tan A plus B can be written as sin A plus B upon cos A plus B. Okay, now substitute sin A plus B and cos A plus B. Sin A plus B is what? Sin A cos B plus cos A sin B upon cos A plus B is what? Cos A cos B minus sin A sin B. Now, if I divide this with cos A cos B. So, this will be written what? Sin A cos B upon cos A cos B, and here cos A sin B upon cos A cos B divided by cos A cos B, here cos A cos B upon cos A cos B minus sin A sin B upon cos A cos B. So if you check here, cos B will get cancelled. Here cos A will get cancelled, and this whole term is getting cancelled. Now sin A upon cos A will be written as tan A, and sin B upon cos B will be written as tan B upon 1 minus sin A upon cos A tan A, sin B upon cos B is tan B. So this way we got a very interesting identity, tan A plus B, and that is tan A plus tan B upon 1 minus tan A tan B. But dear students, please note that here it is sin A plus B upon cos A plus B. So this will not be valid if cos A plus B is 0. So cos A plus B should not be 0. And what are the angles where cos is 0? In pi plus minus pi by 2, in pi plus pi by 2. So A plus B should not be equal to n pi plus pi by 2. Okay, where n belongs to integer. Now we have divided here with cos A cos B, so this will also cannot be 0. So cos A into cos B should not be equal to 0, which means A and B both should not be n pi plus pi by 2, where n belongs to integer. Let me write here correctly, integers. Okay, so this tan A plus B identity is correct if A, B and A plus B, these angles are not equal to n pi plus pi by 2. Got it? Where n is integer. Okay. Now, if I replace this B with minus B, so here also I can write tan A minus B. Tan A minus B. What will be that? That will be tan A plus tan minus B. Tan minus B is minus tan B. So minus tan B upon, here also tan A will remain tan A, but tan B will become tan minus B, and tan minus B is minus tan B, and minus minus will become plus. So at the end it will be 1 plus tan A tan B. This way we get tan A minus B, but again the same rules will be applicable. A, B and A minus B. These angles should not be equal to n pi plus pi by 2 where n belongs to integers. Got it? Now, if I try to find cot A plus cot A plus B. Okay, cot A plus B will be what? Cot A plus B will be uh, cos A plus B upon sin A plus B. And this is nothing but the reciprocal of tan A plus B. So we will get what result? 1 minus tan A tan B upon tan A plus tan B. Now if tan A is written as 1 upon cot A, tan B is written as 1 upon cot B. Here also tan A 1 upon cot A, tan B as 1 upon cot B. Then what will happen? I will write here. So if you solve, it comes as cot A cot B minus 1 upon cot A plus cot B. But again here sin is there. So sin A plus B should not be equal to 0. And if sin A plus B not equal to 0, sin 0 or n pi. For these angles, sine will be 0. So, A, B and A plus B. These angles should not be equal to n pi, where n belongs to integers. Okay? This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.